So now that we have our formula, right, for working with annuities, we're going to look at some examples, right? And just remember a couple of warnings, and we talked about this before in the last couple of lectures. When you go to your calculator, don't forget it doesn't hurt to throw extra parentheses around the numerator and denominator. That helps to prevent any possible confusion on the part of your calculator. And also, you really need to do these in your calculator in one pass, right? Don't try to write down intermediate numbers, right? Don't try to do this part and make a number out of it, and then this part and put a number in there, right? Anytime you start rounding, you introduce a little bit of error, and when you start raising to decimals, or when you start raising to powers and multiplying and dividing by decimals, that error can become magnified, and your final answer can end up being significantly off base. Right, so let's jump in here. Right, so let's see. Suppose you plan to retire in 20 years. Okay, that's good. I've got a time frame here, and you plan to put $350 each month into an annuity. So right there with these, it kind of gives it away, right? I know I'm talking about an annuity situation. Earning 7.5%. How much will you have when you retire? So I'm looking for the future value. All right, so let me get my annuity formula. This is the big mess, right? This R is out in front. 1 plus R over N to the NT minus 1 over R over N. And let's pull out our pieces. A, R, lowercase r is a little unfortunate when you use a variable twice like that, but that's okay. N and T. Okay, A is the future value. That's how much I'm looking for, right? How much will you have? Capital R is the payment. That's $350 a month. Little r is the interest rate, 0.075. And we're doing this monthly. Right, so N is going to be 12. And T is the time. We're going to let this ride for 20 years. Okay, so go over your formula. 350, 1 plus 0.075 divided by 12 to the NT. So that's 12 times 20 minus 1 over 0.075 divided by 12. Now you go to your calculator, and like I've said, right, don't be shy about adding parentheses to the formula. Right, you go to your calculator, you put these numbers in, you are super careful, and you would end up with $193,805.75. Okay, so this isn't up there, but let me ask kind of a supplemental question here. How much interest would you have earned in this scenario? Right, well, don't try to make this complicated. Don't try to go to formulas or any of that kind of thing, right? Remember, interest is equal to how much you ended up with. That's the 193 grand here. How much you ended up with minus how much you put in. Right? Well, how much did you put in? Well, you put in $350 a month for 20 years, and there are 12 months in a year. Right, so let's see if I get my calculator out. 350 times 20 times 12. You put in $84,000. Well, if you subtract that from the 193,805 and change, you get the interest is $109,805.75. Not bad, right? Not bad. At this point, we're really, I think, starting to see the real power of compound interest. If you have time, right? If time is on your side, this compound interest process can really do some nice things to an investment. All right, so we've got another one here, right? You can pause this if you like. Maybe kind of try to work this out yourself, all right? And then we'll do it together. All right, so we're planning on purchasing a house in 3 years. That's my time frame. and I want to have $10,000. Okay, that's that's what I want to have, right? That's the future value. So that's going to be my A in a minute here. How much would you need to put into an annuity? How much would you have to put in into an annuity? So that's going to be my monthly payment, earning 14%, right? To have that amount. So again, let's go to our formula, right? A R 1 plus R over N to the NT minus 1 over R over N. Let's get our pieces. A, capital R, lowercase r, N, and T. Okay, so the amount that's my future value. I need to have $10,000. The monthly payment, that's what I'm trying to figure out. The interest rate is 14%. N is 12. We're doing this monthly. T is 3 years. Okay. So let's jump over here. 10,000 equals R 1 plus 0.14 divided by 12 to the 12 times 3 minus 1 over 0.14 divided by 12. Now again, I know this is looking really nasty, right? But look, it's not that bad. This whole big thing over here is just a number, right? So I'm going to go to my calculator. I'm going to very carefully enter that number, and I'm going to get 1,000 equals R times 44.4227995. Remember, I'm doing this just so you can see what I'm doing. If you're doing this on your calculator, please don't write that number down. You use your calculator's memory button. You use your calculator's answer key, right? So that when you do the division, when you divide both sides by this number, you are getting all the decimal points of accuracy your calculator brings to the table. All right, in this case, I get R is $225.11. Right, that's my future value. Okay, so where are we going to go next? Well, we've been talking a lot about investments, right? Situations where you're putting money into an account and letting it grow. Well, in the next several lectures, we're going to kind of look at this from the other perspective. We're going to look at this from the perspective of a loan. Right, let's say you have taken money from someone, you have borrowed money somehow, and you have to pay it off. Right? How can we figure out things like the interest that you owe? If we're talking about credit cards, that's where we're actually going to go in the next lecture. And again, think about payments. What if you're doing something like a car loan or a home loan, right? What's called an installment loan. How can we figure out the monthly payment that you have to pay, right, to pay off the money that you borrowed?